Web3 represents a new phase for the internet, one that is powered by blockchain technology, which enables decentralization and token-based economies. I'm Víctor Muñoz, developer advocate at Metis, and what I have learned will make you wonder about our future. I'm excited to introduce the Web3 Devs podcast. Rami, so let's imagine that I'm building my first dApp. And then, since I don't know too much, not only about the security practices, but also about the tools, what would you recommend for developers when it comes to tools for enhancing security?
So, like I said previously, we can we the first thing to enhance the security is to test your dApps to properly test the contracts, probably test the backend if it has some permissions on the contract. Um, just of course, do audits. It's a must. Like, I don't have to even say it. You should audit the smart contracts. Sometimes you should even audit the backend if it has some sort of a privilege on the smart contract. Like if the backend has an admin role that interacts with the smart contract, you should also audit it. I mean, there are a lot of auditing teams out there, and they range from cheap to expensive. They range from very very detailed audit to something general for simple smart contracts. Of course, if you're doing an ERC20 token or something very very simple, you can go with a very generic audit, because I mean, sometimes if you don't change much logic in the libraries that you're using, then sometimes the contract doesn't even need an audit. But yeah,
Mm.
you need to be careful about the configuration. You need to be careful about the testing and everything, and then the security on chain. When it comes to on chain security, how to protect the dApp on chain, you can first, when writing the smart contract, you can keep in mind that this smart contract can be hacked sometime, right? And I also said previously that you can implement some logic into the smart contract that allows the admin to pause the contract, to stop it from working, or from moving funds or wherever, until some bug gets fixed, until the admin unpauses the contract, or there are a lot of other ways to do that. Like I said, the on-chain security, you can start planning for it when you're writing the contract. Start planning for the contract to be hacked when you are writing it. Just to have a plan when you find a bug, or when you find something, and you don't want a hacker to front run you and do something with the contract. So you want to fix
Mm.
the bug before a hacker finds it. So you might need to pause the contract or do something like this.
Mm.
Another way to detect malicious activity is by using some monitoring tools. There are plenty of monitoring tools out there, like blockchain forensics tools, for example, like Falcon, Blocksec. A lot of these tools can help you understand the transactions that are happening. They can also I think some tools can give warnings about some transactions that seem to be cracking some logic in the contract,
Mhm.
or taking illegal funds or something like this. So yeah, when it comes to on-chain security, the tools you can use are mostly monitoring tools, are mostly implementations in your contract in case of hacks. Yeah, these kinds of stuff. Also,
All right.
if you're working with something that uh, with a contract that that you might want to change later, or that there's some bug that might happen, use upgradable contracts. But of course, like you can use the proxy library, the open Zeppelin libraries, or like the well-known libraries for this, just so that like you don't implement the proxy yourself. Sometimes like it's too complicated to do that, and yeah, proxies are usually a good idea, like upgradable contracts.
So, for the people in the audience that don't know what a proxy is, could you explain what that is in very simple
Absolutely,
terms?
sure. So first, I need to explain a fact about smart contracts for those who don't know. So when you deploy a smart contract to a blockchain network, to an EVM blockchain network, this smart contract code is immutable. You cannot change it after you deploy it. So you wanna batch a bug, you wanna do an upgrade, you wanna add a feature, you cannot change the smart contract code that you have deployed. And so one way, like one workaround for this, is to have the logic smart contract. So let's say you have an ERC20 token that you want to deploy, right? And you know that later you might want to upgrade this token, add some feature later that you're currently working on, something like this. And so what you would do is you would have a logic contract for the token, all right? A contract that like has all the logic, all the functions that are necessary for moving things around in the token, and you can have a proxy contract. And so this logic contract sits under the proxy contract, all right? Both of them are contracts that do not change in code, all right? But so instead of your users calling to the token smart contract, they would be calling to the proxy, and the proxy would be relaying their call to the token smart contract, all right? And so in this proxy, there's the implementation address, which is the address of this token that you set it to be. And like you can change the implementation address because it's a variable inside, like it's in storage. So once you upgrade to a new smart contract, to a new token smart contract, you can change this implementation address on the proxy. And so this old token contract goes away. It's just like a useless contract, all right? And here comes the new one that you set it to be in the implementation contract. So now you have a new token after you deploy the new token smart contract, all right? And after you get the deployed address, you put it in the proxy, like you update the implementation address in the proxy. And so then when your users talk to the proxy, all right, when your users make calls to the proxy relays their calls to the new token smart contract, so they can use the new features that you have added to the smart contract. This can be expanded a lot. This is actually a very nice topic. I can expand just like for a minute or two. I'm not going to waste the whole podcast on this. This is actually a very interesting topic. So how is this made possible? There's something called a delegate call, which, so when you call a smart contract, there's the message value, there's message dot value, message dot sender, message dot etc. Like there's a lot of things here, all right? And so the delegate call takes this message as it is and sends it to this implementation smart contract, all right? So the proxy makes a delegate call with your message, all right, to the token smart contract, and it works as if like you have made the message directly to the token smart contract. But what is different here is that the value that you have sent and the storage are on the proxy smart contract. So the token smart contract only acts as an execution layer here, like as a blueprint for how the execution should work for the logic. But it doesn't store any tokens, doesn't store any value, doesn't store any storage. all right, it just stores the code, and when you do a delegate call, it's as if like this proxy smart contract has the function that you did the delegate call to, and it executes on this address, the proxy address, not the implementation address, right?
Mhm.
And so here, what this allows us is when you upgrade the token, like when you upgrade the token smart contract and you change the implementation address on the proxy contract, it means here that so let's say like there was stored 10 Metis tokens on the contract, on the proxy contract, which is like in fact the token contract in a way. So when you do an upgrade, these tokens don't go away, they stay the same, and the storage doesn't go away. So if you're storing that this user has 10 points or something like this, this storage doesn't go away, it stays in the proxy contract, so you can still reuse it. These are called like eternal upgradable contracts. There's a lot of types of upgradable contracts, but yeah, most of them are like eternal. They have this storage and value and everything.
Got it. Got it. Super interesting topic. At some point, we have to talk more about it in the future. Uh,
Yeah.
but right now, I wanted to switch a little bit because uh, I wanted to talk about like the implications of artificial intelligence. So we have seen massive progress in this area with ChatGPT and whatnot, and a lot of people are scared about like how is this going to affect security on the internet and of course on crypto, on blockchain, Web3. So I wanted to know a little bit more about your view on the subject, and where do you see that we can use artificial intelligence to kind of enhance security?
All right. So artificial intelligence is very good at detecting patterns. Is very good at like generating as we see with ChatGPT, is very good at generating text, generating like natural language and so on, and good at also understanding natural language. Uh, and so like you can use AI for a lot of different things, and I can see like AI will be able to detect fraudulent transactions or like hacking transactions faster than humans can. I can see that AI. I'm pretty sure that there is somebody right now out there in the space doing this. Like,
Mm,
uh, not sure. Like, I cannot mention the company names, but I think I like seen a lot of companies that are doing transaction detection with AI.
sure.
So like AI that can detect if your transaction is fraudulent or is this a hack transaction. Um, you can train AIs to like detection between like real and fake and hacking transactions. You can also train AI to understand smart contracts, to audit smart contracts. Like there is a lot of AI auditors right now. I see there's like some tools that you can literally just plug into Etherscan, and they would audit the smart contract like without paying 10,000, 20,000 to a team to just look at the ERC20 token smart contract. I mean, like, of course, it's always better to have a human looking at the tokens or at the contracts. I mean, but like, it's quite interesting that uh, these AIs usually find some nice bugs, some bugs that like it, I mean, yeah, humans can find, but you're paying a lot to humans for AI to find the bug very fast, you know, and like they can
Yeah.
generate very very nice reports on the contract. So this is all, yeah, this is one of the things. Uh, Another thing is to like just have AI help you with coding. Of course, there's Copilot right now. It was my best friend for a while, but now I kind of stopped using it. Went back to just raw coding. But yeah, like these tools can help you write good code, can help you like focus on reviewing your code instead of focusing on like writing code and then reviewing it. Like they can reduce a lot of the time that you use to write the code, you know. And so when you have more time to review, more time to look at the lines of code that you and the AI have written together, it means that you might be able to detect more bugs. And yeah, one of the things also AI can help you with writing the tests. Of course, the part that we said is very important. Yeah, like if you're too lazy to write tests, AI will definitely help you to do that.
AI will help you to write this. That's for sure. Okay,
Yeah.
that's amazing. Yeah. Yeah, I can see a future in which auditors work hand to hand with AI because let's face it, it can process information much faster and it can help you, but it still needs supervision, right? So, the last question that I wanted to ask you today, Rami, is about our dear sequencer and its security, right? Because it's one of the main issues, right? We wanted to, decentralize our sequencer to improve participation, resilience of the network, and of course, with that comes security. So, how does that work with our sequencer networks? How does it enhance the security? What are the plans for the future when it comes to that?
All right. So, very interesting question, and this is something that I really want to talk about. So I'm working like day to day with the sequencer dev team, and like the code is being reviewed many times. This is, I would say, like the 10th time the code gets reviewed. Of course, like every round we do some changes. Every round there are some features being added. Every round there's a bug found. Bugs were found, and this is like a very, very good thing. Community testing was a very good thing that we have done because we have found a lot of bugs, a lot of areas where we have improved, like some areas that we can even improve in testnet that we haven't seen like before. I mean, in terms of scaling and so on. In terms of security, also, we have audited the smart contracts so far 2 times with 2 different auditors and like 2 very well-known big names in the industry. I think like as soon as we open source the repositories and the code, these names will be known to public. Or as soon as we make an announcement on the partnership, these names will be known. But like these are the best auditors in the industry,
Awesome.
and so yeah, and they were not forgiving. They were not merciful. They found bugs and like they made us fix them, made us fix everything almost. And we're also gonna go for a third round of auditing. So this thing would be like really resilient.
So,
And
just for
also,
the people, one quick question there, because just for the
sure,
people that are asking themselves right now, why do you need like a second and third round of auditing?
why do you need a second and third round of auditing? It's because the thing is like we kept adding features and features,
Mm,
more features. This is actually one of the reasons why it was like so delayed, the
mm,
decentralized sequencer. Like it started as a small idea, and then we kept adding stuff on top, and then like we ended up with this great system. So the first audit was for the like for the, I mean, for the proof of concept. um, then we made some improvements. We made some changes that can help the system scale even more. And so that's why we did the third round of audit, the second round, I mean.
mhm.
And in the second round, we found some critical bugs from the features that we added. And this is like, in my opinion, this is great. Now we are fixing these issues, fixing these bugs, and that's why we're going for a third round. The third round should be the final one.
Mhm.
It should be like the one that says everything, because I think in the previous 2 rounds we found mostly everything, most of the bugs, and now like we are just fixing the findings. And so the third round is for the final fix, like for the production version of the contracts. And also there will be, other than that, there will be a bug bounty that we're going to be opening soon. Everyone will hear about it. It will be very big. Other than bug bounty, there will be, of course, like a lot of monitoring. This is a very critical update. There will be like real-time monitoring, notifications, everything, get out of sleep notifications, something like this. Yeah, this is what we're planning to do, like especially with such a critical system. I mean, like at least for the first year, and then once it becomes more and more permissionless, once it becomes more and more decentralized, it becomes the responsibility of the sequencers themselves. Like once we give more and more ownerships, more and more ownership to the sequencers and to the community, this becomes their responsibility, and then we will be able to sleep. But like we just need to make sure that the code that we have written, the upgrades that we have done, they are really resilient, as resilient as we see them, and as resilient as the auditors see them. We need to see them work in production. I mean, like we are pretty sure everything is resilient. Everything is just like how to say, flawless, I would say. Yeah,
Great
the
word.
way we see it right now is flawless, but of course we need to be very careful.
Absolutely, absolutely. I take your word on this. I know that at Metis we take development very seriously, and we have been keeping improving since day one. And yeah, I'm absolutely excited about what comes for the future, because the decentralization of the sequencer really what means is not only more security for the network, but also like revenue sharing and
Sorry.
participation for other players in the game. More people are going to come and join our network. They will be able to run other sequencers. So I'm pretty excited about the things that are coming into the future for Metis. Thank you so much for joining today, Rami. I think we have completed a great first round of episodes for the podcast, and it has been an amazing experience recording this with you.
Thank you, Victor. I really enjoyed the recording with you.
Awesome, man. Talk to you later. Bye
See
bye.
you on the next one. Bye.
See you in the next one. I hope you enjoyed this episode. If you did, or if you learned something new, please subscribe to this channel. It helps us more than you can imagine. See you on the next episode.